Okay, so here's a quick review that we're going to do before your Chapter 7 exam. I'm going to go through it relatively quick because these are things that we've already learned and we've practiced, and this is just a brief review to refresh your memory before you take the exam. Okay, so here we have a line on a graph, and we need to write it in the slope-intercept form of a linear equation. It is called the slope-intercept form because you can see right away the slope and the y-intercept. Okay, so the first thing I always like to find is the y-intercept. So that is wherever we are crossing the y-axis. So we cross the y-axis right here. Unfortunately, I just noticed that these are not numbered, but let's go ahead and just assume that they all go by ones. Okay, you can add this if you want. Okay, so we know now that the y-intercept is -1. We need to find the slope. So the slope is always rise over run. So we need to draw a slope triangle. Now you can use any two lattice points. So I have two already marked right here and right here, but you could also find this one is a lattice point as well. It does not really matter. I can make a slope triangle that is this big, or I can make one right here, or I can make one right here. And it does not matter which one. So I'll just go ahead and use the two that we were given. So I go from one point to the next. This is my rise and this is my run. So I count each jump and they're just going by one. So I go 1, 2, 3. That is my rise. And then I go 1 to the right. So that is my run. 3 over 1 is equal to 3. So now I need to write it in the form of y equals mx plus b. I know my m is 3. Okay. And I know my b is a -1. So now I just write y equals 3x minus 1. That is my equation. Okay, so pause the video if you're still getting this down. I'm going to move on to number 2. All right, so this one says this line goes down as you go to the right. So from left to right, the line is going down. That means the slope is positive, negative, or 0. What would you say that the slope is? Hopefully you said negative. This one is negative. So positive would look like this. Negative is going down. If a slope is 0, that means it is a flat line. It has no slope. Okay? All right, so here's another one. It's asking us to write the equation for the line. So the first thing I'm going to do is find my y-intercept. All right? So my y-intercept, I cross the y-axis right here. Now, I'll tell you right now, what a lot of students have done in the past is say that that's at -5. But -5 is right here. That is not where the line crosses. So you can see here that we go by ones every unit for this graph, just like the one before. -5, -6, and so on. Okay, so you have to be super, super careful. Right here, that is at the point -4. So our slope is -4. Now, if I were to draw a slope triangle, I need to find my lattice points. So this one looks really close, but it does not cross perfectly right there. It's just a little off. So we can't use that one. But this one right here is a perfect lattice point. So we know that the line crosses right through that point. So we can use that to draw a slope triangle. So I always go from the point that's on the left side of the line, whether it's a negative or positive point. Some students do this instead. You just have to make sure to keep the rise and the run where they need to be. But I like to do this because I always like to draw the rise first and then the run. And then also, if I go from the leftmost point to the right point, I go down for my rise. And that reminds me, oh yeah, it's a negative line because I'm going down from left to right. Okay, so here, since we're going by ones, we can count 1, 2, 3, 4. So for my slope, rise over run, my rise is a -4 because I went down 4. And now if I look over here, I go 1, 2, 3. So my run, I went to the right 3. So my slope is -4/3. If you were to divide that, you would get a bad repeating decimal. So let's just leave it as a fraction. So my equation is y equals -4/3 x, and then my y-intercept was -4. So this is your linear equation here. Okay. Go ahead and pause if you need to. I'm going to move on. All right, number 4, it says the number of hours spent hiking in Yosemite and how much water is left in your water bottle. What association is this? Well, let's think about it. For hiking in Yosemite, the more hours we spend, so let's draw this. Let's do hours here and water here. The more hours you spend hiking in Yosemite, the more water you're going to need to drink to stay hydrated. Let's assume that at 0 hours, we had a full water bottle. So our first point is right there. We had a very full water bottle, okay? But as you start hiking, you're going to start losing the amount of water in your bottle because you are drinking more water. So the more hours you hike, the less water you have. So this would be which association? I'm going down from left to right. It's going to be a negative association here. Okay, pause if you need to. Number 5, it says the time spent driving and the car mileage. How many miles the car has traveled is what the car mileage is. What association? So let's think about it. Here we are comparing the time spent driving. So that's going to be on my x-axis. Time usually goes down here. Time driving versus the miles driven, or the mileage, but it's really just the miles driven. So whenever we first start to drive, we would be at 0 minutes. How many miles have I driven right as I start to drive? 0 minutes. How many miles have I driven? 0 miles, right? So this one should start at 0, 0. And if I continue going with the same speed, I'm going to increase at a constant rate, increase the number of miles driven over a constant time. So as I spend more time driving, I'm going to be driving more miles. So this is a positive association. The more I drive, the more miles I drive, right? The longer I drive, the more miles I drive. Makes sense. Number 6 is the height of a tree in a student's shoe size. Shoe size. What association? Okay, so the tree, I'm looking at a tree right across the street at my neighbor's house. That tree is super tall. Does that mean my feet are really big? Or the tree next to it, that tree is super short. Does that mean my feet are small or that my feet are big? There's no association here. No association. None. There's no relationship between the height of the tree outside and your shoe size. All right, use the line at the right to predict the weight of someone whose whose height is 45 inches. So we know the height. So that's the first thing is we need to find the height on the graph. So I look at what's labeled on the y-axis and the x-axis, and I notice that the height is on the x-axis. So 45, this is what I'm given for the height. So to try to predict their weight, we want to use that line of best fit. So I'm going to go straight up, and then from there, I'm going to go straight across until I get over to the x-axis. So I get right about there, almost to 100, but not quite. So my prediction is about 98 pounds, I'll say. That's how much somebody who is 45 inches tall is approximated to weigh based on this data. Okay, if you had the graph or the equation of the line, you could have also plugged in the height 45 for x because it's on the x-axis in the equation. So you can plug that in for x and solve with your equation and then solve for the weight. That would be the y because it's on the y-axis. Okay? All right, so use the line at right to predict the height of someone whose weight is 120. So this time they give us the y here. They give us the weight, okay? They say that their weight is 120 pounds. So let's use this data to predict how tall we think somebody might be who weighs 120 pounds. Again, this is a prediction. It's not for sure. It is a prediction. Okay, so from 120, if I go straight across, you can always use a ruler too. And then I go straight down from that line, I hit 55 inches. So my height prediction is about 55 inches tall. This one, you would have plugged in 120 for y and then solve for x if you had the equation. Now, this problem does not ask us for the equation, so it's easier to just use the line of best fit. Okay? All right, we have two left. So this one says set up proportions for this problem and solve. So we have Lori can type 70 words per minute. At this rate, how long would it take her to type 540 words? Well, we can set this up as a proportion. So we know Lori can type 70 words in 1 minute. We want to know at that rate, how long would it take her to type 540 words? We don't know how long, so right there we're going to put an X, because that's where the minutes line up. The minutes line up down here, the words line up here, okay? So now we can cross multiply. We're going to have 1 times 540 is 540. Then we have 70 times x is 70x. And we set those equal to each other. So now I can divide. So let me pull up my calculator. I'll show you why I have to divide. I forgot to show you the step. But we're going to get 540 divided by 70 is approximately 7.71. And this is why we would divide. Here, in order to solve for x, we have to undo the multiplication of 70 by dividing by 70. 70 divided by 70 is just 1. 540 divided by 70 is approximately 7.71. It's approximately x. So it takes her approximately 7.71 minutes to type 540 words. So 7.71 would be your answer there. Okay, so pause if you need to. Last one. So set up a proportion for this problem and solve. Lisa rides her bike for 5 minutes and travels 820 feet. So I'm going to write that down. In 5 minutes, Lisa travels 820 feet. Okay? How long does she need to ride to travel 2,000 feet? Well, should I put the 2,000 feet on the top or the bottom of this fraction here? I need to put it on the bottom because my 820 feet is on the bottom on the left fraction. So I'm going to put 2,000 feet here. And we don't know how long she needs to ride her bike to go that far, so we're going to put an X here. And now we can cross multiply. 820 times X is 820X. 5 times 2,000 is 10,000. So now to get the X by itself, we're going to divide both sides by 820. Because 820 divided by itself is just 1. So I have 1x left. And let's see what 10,000 divided by 820 is. It's about 12.19. Okay, so she will need to ride for about 12.19 minutes to travel 2,000 feet. That's what it would be paired up with. Okay, so hopefully this gave you a good review. Another good thing to review would be the Chapter 7 study guide packet that we did in class just a few days ago. Okay, this is the other thing that would help you really prepare for the test. The most important things are here on page 2. I did all of this in a video. And then here's more examples on page 3. So if you struggle on the test, go through these pages 2, 3, and 4, and they should help you for the test. Good luck.